These notes are for 8.2, day 2. This is the second page. Your long distance calling plan has a fixed monthly fee of $4.95. So every month it costs at least that much. And it's going to cost you 5 cents for every minute that you talk. Write an equation that gives your average, that's the key here, your average cost per minute during the given month. So we know that your cost is going to equal 5 cents per minute plus the fee of $4.95, all divided by the number of minutes, because it's the average cost per minute. So this takes your total cost and divides it by minutes. So we're going to come down to graph this. We'll make a table. We're going to put our minutes in here, and we're going to have our cost per minute in this column. Well, they ask us to graph one out at 20 minutes. What if you talk for 20 minutes and you type that into your calculator? 0.05 times 20 plus your $4.95, and divide that by your 20, and you're going to get that each minute costs almost 30 cents. When we plug in 40 to the equation, 5 cents times the 40 plus the $4.95 divided by 40 gives us 17 cents per minute. So it's actually costing you less money the more you seem to be talking per minute. But because you're talking for a longer amount of time, the fee is going to go up, but cost per minute is cheaper. And then finally for 80, 5 cents times your 80 plus your 4.95 divided by the 80 brings the cost down to just over 11 cents. So we'll come over to graph that. At 20 minutes, we were just about at 30 cents per minute. At 40, we were well under the 20 cents. At 60, we were over 13 cents. And at 80, we were just over 11. So we want to watch, where is this coming down? Now, where's the asymptote going to be? Where would a horizontal asymptote be? If we look at our equation, we both have a degree of 1. So at 0.05 is the cheapest this could ever become, but it'll never reach that because of our additional cost. So we'll call this our 0.05 line. So it's slowly approaching 0.05. What happens to the average cost per minute as the number of minutes increases? As the minutes increase, the cost per minute approaches 0.05. In summary, the graph of the function y equals 1 over x is a hyperbola. The graph of the function y equals a over x minus h plus k, this is our rational equation that's been translated, has asymptotes at y equals k and x equals h, very similarly to what we've done all year. The graph of a simple rational function is a hyperbola, which is a curve made up of two branches. These graphs have one vertical asymptote and one horizontal asymptote.